Hi, welcome to this video. In this video I'm going to explain and demonstrate the functionality of the Jota game board, which is programmed with the YAL programming language. So what will be the contents of this video? First, why I did this project. Then the features of the Jota game board. The schematic diagram that's being used for this board, and then the final hardware. I will give a short explanation of the software functionality, and of course there will be a demonstration video. And at the end of this presentation you can find some references. So why did I do this project? I have a colleague who is working for the scouting in the Netherlands, and he had a board which he purchased in the past, but it could no longer be purchased. So he did not request it, but I offered to make a board which does more or less the same thing. And it is meant for the scouting, where kids can work on electronics, and the board then functions as a soldering kit. And it's partly based on an existing kit which was developed in 2010, and it was called the UB game. But I added some new functionality, new features, and I also added infrared communication. I also added the possibility to reprogram it so that kids can make their own games. And a requirement was that the board should be inexpensive. So the board, including the electronics, should cost no more than €5. So what are the features of the game? In fact, there are 8 user features which you can select. There's a lighthouse LED pattern, a snake pattern, and a Knight Rider LED pattern. So these are the patterns, no games, but there are 5 games remaining. One is Simon Says, which is a memory game, a Jota game, which is a reaction time game, a Pong game, which is also a reaction time game. There's a Morse game. This uses one-way infrared communication, so you can send Morse signals to another board. And there's a battleship game, and this one uses two-way infrared communication. And there is also a feature like auto reset and auto power down, and this is developed to save the batteries. So the schematic diagram looks as follows. The heart is formed by the PIC microcontroller. Then we have 8 LEDs which we call the game LEDs, and they are also used to select the functionality. We have 3 status LEDs, one indicating that the game is being played, and one LED indicating that it was successful, okay, or not successful, so not okay. Then we have 2 switches which are used to play the games and control the board. There is an infrared LED and there is an infrared receiver. And the whole board is powered by 2 AAA batteries. And for reprogramming the board, there is a connector to which you connect a Picket programmer. So for this board I really made a PCB, printed circuit board, and if you assemble it, the board looks like this. So at the top you see the 8 game LEDs, and there are also times mentioned, and those are used for the reaction game. So you have to add up the various times to get the total time of which is then the reaction time. So the software is written in YAL. It takes about 5K of ROM and 160 bytes of RAM. But the PIC itself has 8K of ROM and 1K of RAM, so there's sufficient room to add new games or change games. And the main program handles the initialization of the board and the menu selection, and all the other source files are library files which are created. They set the PIC configuration, they handle the switches, all the LED patterns and the games, the timer, and also the power down feature. And I'm using a few YAL libraries. One is of course a device file for the PIC. I'm using the EEPROM library in which the infrared address is stored, and I'm using a random generator library. So the demonstration video, I will show the following. I will install the batteries, and then the device starts up with showing a random LED pattern. Then I will give a short demonstration of all user features. And I will also show the power down mode. First I will select a Pong game as an example, and I will not play the game for 5 minutes. I will shorten the 5 minutes, by the way, for this video, but after 5 minutes there will be an auto reset, which is more or less the same as installing the battery, so it starts with the random LED pattern. Then after 1 minute the random LED pattern switches to the walking menu pattern. Then after 2 minutes the walking menu pattern switches to the lighthouse pattern, and then after 3 minutes the lighthouse pattern switches to the power down mode, saving the battery.
So I have two modules. The module on the left has the infrared receiver and infrared LED on the front, and the right module has the infrared LED and infrared receiver on the back. And I start with the right module by inserting the batteries. So you see the random pattern, and when I press a switch I can go to the walking menu. The very first option is the lighthouse. Okay, then the second one is the snake pattern. The third one is the Night Rider pattern. The next one is Simon Says. So I have to select the correct LED, and then if I press a little bit longer it says OK. Then it goes to 2 LEDs. This was wrong, so we try it again. It starts with 1. Continues with 2. First, second, this was easy. And so on. I will make an error, and then the game stops. Okay, next one is the reaction time game. So I get a reaction time and I have to respond within this time. Then the next will be a little bit faster, and the LEDs indicate you have to count the numbers on the above the LEDs to get the correct time. Okay, so the next will be faster again. Now I will not press a switch so that it will time out and the game is over. Okay, this is the score. Next one is the Pong game. So it goes a little bit faster each time. Oh, I was too soon. I will end this game. This is the score. Next one is the Morse game. You have a dot and a dash that I can send to a receiver. If I select the right switch, I'm the sender. If I select the left one, I'm the receiver. So I will select to be the sender. But I need a second module. It's this one. So I can switch it on. It's from power down, so it goes first to the lighthouse. Then we go to the same game. And we select to be the receiver. So I can select a dash and I can send it. I can send it again. I can select a dot and oops, I must not be in the way, of course. I send the dot. Send it again. Select the dash, and so on and so on. I can end the game pressing 2 switches, and I have to do it the same here. We'll select the last game, which is the battleship. I get 5 random ships. If I press a key, I select that one. Same here. I get 5 ships. I select this one. Now I'm only going to shoot from the right module to the left, but the left module can also shoot back. So I select a ship, and there it goes. I can try that again, but there's no ship, of course. Then I will shoot all the ships on the other end until they're all gone. So this is the last one. I get a message back that I shot all the ships and I won and the other party lost. So that's it. Let me put the module back to the lighthouse. And the same here. So this is the demo of the auto reset. So first we wake it up, then we select the Pong game, just an example, and we keep it like this, and then after 5 minutes it will reset.
If you want to have the sources for this board, the hardware, the PCB design and the documentation, you can find it using this link. If you want to know more about YAL and about the YAL programming language, you can visit the YAL website. If you have questions on YAL, you can download the YAL lib tutorial, which is on the website, or you can post your question in the YAL Google group. If you find bugs in YAL, in the YAL libraries or YAL compiler, or you have specific requests, you can visit the YAL lib Google group. And if you want to know more, all the sources that are used for creating YAL, you can find them on GitHub. I hope you liked this video, and thanks for watching.